Alright, so this video is on necessary and sufficient claims. We know from your textbook that necessary and sufficient claims relates to conditional claims, and that's what we're going to talk about today. So I have everything that we need on the board to get a conversation going about conditional claims. If you don't have all this kind of stuff written down in your notebook from the last video, then go ahead and pause this video and write it down now. Okay, so hopefully you all already have this written down. So first we have the conditional claim that we used as our example for most of the discussion about conditional claims in the last video, and that's if it's raining then the grass is wet. I also wrote down just how we talk about conditional claims and put the variables in, so that's if P then Q. And we wrote it out in logical notation, so we have the arrow here, and that indicates a conditional claim or an if-then statement. Lastly, we have the truth table up here, and remember, a conditional claim is only false if it's the case that the antecedent is true and the consequent is false. And so today we're going to talk a little bit more about why that's the case and hopefully make some sense about that and motivate it a little bit for you guys so you understand exactly what's going on there. We're going to do that by talking about necessary and sufficient conditions. So what are necessary and sufficient conditions and how are they different from each other? Well, a sufficient condition is something that guarantees whatever it's a sufficient condition for. So rain is a sufficient condition for the grass being wet because when it rains, you're guaranteed that the grass is going to be wet. So a sufficient condition guarantees whatever it's a sufficient condition for, such as rain guaranteeing that the grass is wet. Rain is sufficient for knowing that the grass is wet. Okay, what about a necessary condition? Well, necessary conditions, despite the name and what you might think intuitively, necessary conditions actually don't guarantee what it's a condition for. So the grass being wet is a necessary condition with rain because it is necessarily the case that the grass will be wet when it rains. However, the grass being wet doesn't guarantee rain. Right? There's a lot of different reasons that the grass could be wet. We could have left the sprinkler on, or I could drop my drink outside on the grass. So there's a number of ways that we could end up with wet grass without it having rained. And that means that wet grass doesn't guarantee rain. Wet grass then isn't a sufficient condition for rain. But again, since it's necessarily the case that we will have wet grass when it rains, that means that wet grass is a necessary condition for rain. Okay, so let's go ahead and think about this more clearly in terms of a conditional claim. So first, I want to ask you, what do we call the claim that's in the position that P is in a conditional claim? And what do we call the claim that's in the position that Q is in a conditional claim? All right, so the simple or basic claim that we have in this position in a conditional claim is what we call the antecedent. So this is the antecedent of a conditional claim. And you can remember this if you want by remembering that it's on the left-hand side. Since I told you in this class, that's fine. You can also remember it by the root ante, meaning like before or prior to. All right, and Q is the consequent of a conditional claim. That's the position that it's in. Consequent, same root as consequence, comes after. So we have our antecedent and our consequent. All right, so between the antecedent and the consequent, which do you think is going to give us a sufficient condition and which is going to give us a necessary condition? All right, hopefully that's clear from what we just talked about. So the antecedent is going to give us a sufficient condition and the consequent is going to give us a necessary condition. So the antecedent gives us a sufficient condition, consequent gives us a necessary condition. All right, so let's use this to help us make sense of this truth table. So I think that we're pretty good on the first and the last row. Remember, so a conditional, it makes sense it's going to be true if we have this conditional, like if it's raining then the grass is wet, and it's raining, that's true, and it's true that the grass is wet. Makes sense that our conditional is going to be true. It also makes sense that the conditional is going to be true even if the antecedent and the consequent are false. So remember, it could be something like it's sunny outside, so it's false that it's raining, and it's false that the grass is wet. But the conditional is still true. It's still true that when it rains, the grass gets wet. Okay, so the first row and the last row we're good on, but the middle two rows are kind of weird. So we want to investigate this a little bit further. And thinking about it in terms of necessary and sufficient conditions, it's actually going to help us a lot. So remember, again, a sufficient condition guarantees whatever it's a sufficient condition for. So if a conditional claim is going to be true, then it needs to be the case that the antecedent is guaranteeing the consequent. All right, the antecedent is the sufficient claim. So if our conditional is going to be true, then the sufficient claim and the antecedent has to guarantee the consequent. Well, let's look at the third row. We have our antecedent being true, and yet the consequent is false. So that means that our antecedent didn't guarantee the consequent. That's why our conditional claim is false, because it didn't actually give us a sufficient condition. And in order for a conditional claim to be true, it's got to give us a sufficient condition in the antecedent for the consequent. All right, so since in this third row we can see that the antecedent does not give us a sufficient condition for the consequent, our conditional is false. Let's look at the second row. So we're looking at the second row. In this case, the antecedent is false and the consequent is true, and the conditional claim is true. How can this be the case? Well, remember, the consequent is a necessary condition, and a necessary condition doesn't guarantee the thing that it's a necessary condition for. So it's okay for the consequent to be false, or for the consequent to be true and the antecedent to be false. We can still have a true conditional claim, because the consequent being true doesn't have to guarantee that the antecedent is true. Necessary conditions don't have to guarantee the thing that they're conditioned for. All right? So the grass being wet doesn't have to guarantee rain in this particular example. So necessary and sufficient conditions can help us understand what's going on with this truth table for conditionals and why the second and third rows look kind of wacky when you first look at it. So hopefully that makes a little bit more sense. So really quickly, one more thing on this note that I want to talk about. I'm going to erase this truth table too, so you should have that in your notes and in your book. Okay, so we know that the antecedent is a sufficient condition, and we know that the consequent is a necessary condition. But what happens if it just so happens that P is not only a sufficient condition for Q, but a necessary condition for Q? Well, if P is a sufficient condition for Q, then we're good here. We have it written out in this conditional that tells us that, yeah, P is a sufficient condition for Q. What should we write to illustrate that P is also a necessary condition for Q? We'll need another conditional. And what's going to be in the place of the antecedent? Q. I'm going to say, if Q, then P, right? Because P is a sufficient condition for Q, so we're going to have one conditional in which it's the antecedent, and P is also a necessary condition for Q. So we're going to have another conditional where P is in the place of the consequent. So we have if P then Q and if Q then P. So we have two conditionals. There's actually a word that we can use for this. It might seem kind of obvious, but we call this a biconditional claim. So here we'll say this is a biconditional claim when you have two conditionals. And the way that we talk about biconditional claims is with the phrase if and only if. And hopefully that rings a bell from your textbook, because it talks about if and only if claims. And it writes up if P then Q and if Q then P. It tells you that whenever you see if and only if, that means that you're going to get these two conditionals. We say if and only if. We also write that this is the word if with two F's. That means if and only if. If you ever see that in a philosophy class. If and only if. And we don't actually have to write it like this with the two different conditionals. We can just say, all right, P is a sufficient condition for Q, and Q is a sufficient condition for P. So we'll just make the arrow double-sided here. And that tells us that P is actually sufficient and necessary for Q, and Q is sufficient and necessary for P. What's an example of something like this? We could say P, let's say P is X is a triangle. We'll say Q is X has 3 sides, or like X is a shape that has 3 sides. All right, well, if X is a triangle, that guarantees that it has 3 sides. That's a sufficient condition. And if X has 3 sides, it's a shape that has 3 sides, that guarantees that we're talking about a triangle. So this is also a sufficient condition for this. And they're also both necessary conditions for each other. So in this situation, X is a triangle is sufficient and necessary for X having 3 sides, and X having 3 sides is sufficient and necessary for X being a triangle. We can also say X is a triangle if and only if X has 3 sides. Or X is a shape that has 3 sides if and only if X is a triangle. All right, so that's an example of a biconditional. And I don't know why your book doesn't introduce the term biconditional or the logical notation. So please write that either in your book or in your notes, because it's going to come up on the homeworks and on the exams. All right, let me know if you have questions. Hopefully this helps make sense of conditional claims and the wacky truth table. And then we introduced biconditional claims, so this was a big video. Again, if there's any confusion, don't hesitate to let me know.